Hello everyone, I'm Yvonne, a children's librarian here at the Manchester City Library, and I would like to welcome you to Elementary Experiments. Here we're going to do experiments and activities aimed at elementary grades 1 through 6, with a focus on STEAM, our science, engineering, technology, arts, and math. This spring, we're going to continue to have our in-person events at 3:30 p.m. on the second Wednesday and the fourth Tuesday of the month. We will also be putting up our videos at the same time as our in-person elementary experiments. If you would like to join our in-person activities next time, please visit our website and register. Registering for the event ensures that we have enough supplies for the activities and kits for everyone who attends to take home. Any extra craft kits we are going to put at the children's reference desk, and they will be available for anyone who wants to do the craft at home and is in the correct age range. Now that we have covered all that, let's get into this week's elementary experiments. Hello everyone, and welcome to Elementary Experiments, where this week we are going to be doing a solar eclipse study. Now, as you may know, there is going to be a total solar eclipse that is going to be traversing the country on April 8th, 2024. And actually, the northern part of New Hampshire is going to be in the total eclipse range. So for about 3 minutes and a little bit of change, everything is actually going to go dark in the middle of the day as the moon's shadow will fall upon the earth and block out the sun for a small swath of the planet. So here in Manchester, we are a little bit south of the total eclipse zone. We're going to be somewhere about 95% of coverage. So we will be able to see part of the sun the entire way through the eclipse, but it is still pretty exciting. So I thought that we would do a few models today to sort of get us ready so we can better understand what is going to be happening on April 8th. So there are actually two different kinds of eclipses. One of them is actually a lunar eclipse, which is when the Earth's shadow falls upon the moon, and therefore the moon will disappear during the night when it is normally visible. And the other one, which is the one that we are talking about today, is the solar eclipse, which, as mentioned, is when the moon's shadow falls upon the Earth. And because the moon is so much smaller than the Earth, only a small portion of the Earth is totally covered by the moon's shadow. And that's why we have such a relatively small area where a total eclipse can be seen. And that's why, even though if you're in the very northern part of New Hampshire, you will see a total eclipse. If you're anywhere south of that very, very small sort of panhandle-ish part, we'll only see a partial eclipse. I am going to add another sort of standard disclaimer, which is that you never want to look directly at the sun, especially during an eclipse, but really any of the time. So if you want to view the eclipse, definitely make sure that you get eclipse glasses, and that you want to make sure that you get them from a reputable source. Because eclipse glasses have to be specially made to protect your eyes from the intense light of the sun as you look at it. So it's way more than sunglasses. It needs to be more than just something that looks black. You need to make sure that you are protecting yourself by getting your glasses from somewhere that you can trust. If you don't have eclipse glasses and you cannot pick them up at your local library, or if the Manchester City Library has run out, there are other ways to view an eclipse without looking directly at it. Definitely one of the best ways is to actually use a pinhole viewer or observe the light as it moves through holes. So you can do this by grabbing something that already has holes in it, like a strainer, or what is sometimes called a colander that you would use to strain out like pasta. You can also grab something like this slotted spoon, or you can also go ahead and make your own by taking like a push pin like this and poking holes into a piece of paper. And then what we would do is we would take our thing with the holes and we would stand so that the sun is behind us, and we would let the light shine through our holes. And then when we look at the light that has shone through the holes onto either the ground or whatever we put in front of it, you'll actually be able to watch as the shadow of the moon slowly eclipses the sun. So now that we have covered the basics of what is happening and a little bit on how to be safe, let's get into our first activity where we are going to make an eclipse model to scale. Now you can see a lot of interesting pictures or diagrams of an eclipse that sort of show how the Earth and the Moon and the Sun line up for all this to happen. But one thing that is really hard to understand from these like diagrams is how big space is. It's really hard for humans to conceptualize how huge space is, how much space is in space, and it's a lot. So we are going to build a scale model to show the difference between the sun, the moon, and the Earth, and how everything has to align for this solar eclipse to happen. So let's gather our supplies and we'll get started. So we are going to need to do quite a bit with this one, including a little bit of math. But the first thing we want to try and figure out is if we have enough space to do this. Because as I said, space is big, and so our model is also going to end up being very large in like how to view it correctly, even if our individual pieces aren't necessarily that big. So first off, what we're going to need is we're going to need a space where we can see like in a straight line for about 230 feet, which is pretty big. So you might need to do this outside. The second thing is you are almost definitely going to want or need a partner because of how big and far away some of our pieces of our model are going to be. And of course, if you don't have a space big enough right now, you can always make the pieces and then take them to a larger space like a park or somewhere else. So other than that, what we're going to need is some yarn. It's not going to be a ton, but I have this here. We need a ruler. It's definitely important for this one because, as I said, we are going to need to do some math. We have a hole punch. We've got some toothpicks. We've got a little bit of clay. We have two sharpened pencils. We have our scissors. And then we are going to need either a large sheet of paper that's about 3 feet by 3 foot, or enough smaller pages to tape together to make that larger paper. Okay, I think that is everything. Oh, and then at the end, when we go outside or into our large open area, you're going to want either tape or chalk, depending on the area, so we can mark where the different parts of our model are supposed to be. But first of all, let's start with the math part. So we're going to need to take our hole punch and punch out a piece of paper. It really doesn't matter the color. I have a little bit of extra white here. So I have my hole punch, and this here is actually funnily enough, our most important piece of our model, because this is our starting point. This is going to be the Earth. We're going to use the size of our Earth to figure out how big everything else should be. My hole punch Earth is 7 millimeters in diameter, and diameter is the distance across a circle, right? So across is going to be 7 millimeters, which is very standard for a hole punch. So I wouldn't be surprised if yours were very close to that. Now what we need to do is to find out the diameter of our moon. The Earth's moon, our moon, which we call the moon, is actually a very large moon. And it is going to be about 1/4 the size of the Earth, right? So that's 1/4 the size of the Earth. So to do that, we are going to take a little bit of clay, and we are going to make a ball that is about 2 millimeters in diameter, which is quite small. So let me see. So here is the moon on our little toothpick, and here is the Earth for sort of scale. It's about 1/4 of the size. All right, so our next thing that we need for our solar eclipse is the solar part, which is going to be the sun. So let's see, the diameter of the Earth is about 100 times greater than the Earth's. So we have to multiply the diameter of the Earth by 100 to find the diameter of our sun, right? So our Earth was 7. So it's going to be 700 millimeters. For us to actually draw out our sun, we want to actually get the radius of the circle. So the radius is the diameter divided by 2. So remember, if we have our circle, the measurement across is going to be our diameter, and then the measurement from the center to the edge is going to be our radius. So if we take our measurement of 700 millimeters and divide that in 2, that's going to be 350. And there are about 350 millimeters in a foot. So I am going to want my radius to be a foot long. So I am going to take some yarn, and I am going to measure a foot. And then I'm going to put a little bit of extra because I'm going to need to tie some pencils. So this is where I'm going to take my 2 sharpened pencils, and I'm going to tie a loop. And then I want to get that 350 millimeters. And I'm going to tie my second pencil. Now I have my apparatus that I'm going to use to draw my sun to scale. Again, you are probably going to want a partner for this. And I still have to put together my sheets of paper because I don't have a sheet that's big enough by itself. But basically what we're going to do is we are going to take our pencils onto our paper that is big enough, and it's helpful if you have one of your partners hold this pencil in the middle of the paper, and then have the other partner or you, depending how many people you have, take this, and you're going to pull the string just a little bit taut, not too hard, and you are going to trace your circle around your paper using this. So I'm going to go ahead and get this taped together and my circle drawn, and then we can see how big the sun is in comparison to our Earth and our moon. So here we have the sun, and then if you recall, we have our Earth and our moon. So if you guys can see, I don't even know if you can, how small they are if they were to be put right up close to our sun. So now you need your large area. So the distance from the sun to the earth is about 100 times greater than the diameter of the sun. So our diameter was 700 millimeters or 70 centimeters. Then that means the correct distance between the Earth and the sun will be 70 meters. And a meter is about 1 yard or 3 feet, if that is helpful in measuring out your distance. So for me, that would mean I actually need 210 feet from my sun to where the earth would be. So I would leave my sun here. I would go 210 feet this way, and I would bring my ruler as well as my earth and my moon. So the distance of the moon's orbit from the earth is about 30 diameters of the earth, right? So if our earth is 7 millimeters in diameter, then we would multiply that by 30. So that would make it 210 millimeters or 21 centimeters. So there we have, there we go, ish, the diameter or the orbital distance of the moon over here and the earth. Because this is where you are going to want to take away the earth, because your eye is now going to be where the earth would be, and then look down at the moon, and you will see the sun all the way down at the end, and that is when you're going to be able to see how something as small as the moon on the very tip of this toothpick would actually be able to eclipse something as big as the sun, just because it and the earth are so far away, that whole 210 feet down. So like I said, it is really cool. Obviously, I can't show you everything here because I don't have the space in this room. But if you take it outside and you get that little bit of extra help from your partners, you'll be able to see exactly what I mean, so that we can see how orbits will affect our solar eclipses. We are going to make for our craft an eclipse in a cup, or 3 cups, as the case may be. So what we need extra is going to be a ball about tennis ball size, an exterior light. So this is a flashlight, and then we have 2 different colors of permanent marker. I actually don't remember if we need scissors, but I've got scissors here. In our kit, if you are able to pick up our kit from the Manchester City Library, and you are in grades 1 through 6, it will have 3 different 9-ounce cups. It's going to have a push pin, and then it's going to have 2 blobs of clay, one that is blue and bigger, and one that is gray and smaller, assuming that we have the same colors throughout. And of course, our instructions as well. So what we're going to do first is we are going to take our clay, and we are going to roll them into balls. So our larger piece of clay, in my case blue, I'm going to roll into a ball, and this is going to be the Earth. Now, if I want to double check, this ball should be about a half an inch in diameter, which is across. So that is fine. And then we are going to take our smaller amount of clay and we are going to roll that into a ball that is going to be our moon. And that should be about 1/4 of the diameter of the Earth. So mine's actually a little bit big. Let's take that down. I'm going to call that good. All right, so our first one is going to be our Earth cup. And basically what we're going to do is we want the top where our Earth is going to sit to actually be even with the center of what we are using for our sun, right? So here would be about here. So we are going to need to trim down our cup. Let's see, like about to here, I think. Okay. So what I'm going to do is I'm going to trim this cup down. And remember, it's probably better to trim less off than more because you can always cut more away, but you can't add more on as easily. So that's about right, I think. So finally what we're going to do for our Earth cup is we're going to kind of stick the Earth ball onto it so that it is stuck on there pretty good, but it's also not squished. It's not deformed. Our Earth is still a sphere. So the next thing we're going to do is make our ecliptic plane cup. We are going to put our ecliptic plane cup in between our Earth and our Sun, and we are going to take our first color marker, and we are going to draw a circle around this cup that is parallel to the tabletop and even with the center of the Earth. So I think that's about right. I'm going to put this here and I'm going to draw as I turn. That made a fairly even line. I don't know if you guys can see it very well on camera all the way around. And then we are going to take the push pin that was in our thing and we are going to insert it somewhere on this line. There we are. This is going to be our ecliptic plane cup. And it's plane as in like a area. Finally, with our third cup here, this is going to be our tilted lunar orbit cup. And to make our lunar orbit, we are going to be measuring about 1 centimeter or about 3/8 of an inch from our brim up. And then we are going to take our second color here, and we are going to draw a line all the way around the circumference. And we are going to do that the easiest by turning our cup. This is where if you have a partner available, it's really good if one of you holds the ruler and the pen, and then the other one can turn the cup to get the most even line. I'm going to have to kind of do both here. And this is where we're going to take our smaller clay moon, and we are going to gently stick it onto the line that we just drew. Like the Earth, we want it to stick, but we don't want to squish it. So there I've got my moon. Next step is to assemble our model or put everything together. So first off, we are going to have our Earth cup. Then we are going to do our ecliptic plane cup. And finally, our lunar orbit cup. And our lunar orbit cup, we are going to set so that it rests on top of the push pin here. All right, now what we're going to want to do is take our sun and put it in the center, and then take our Earth here, and we are going to see if we can get our sun and our moon and our Earth to line up to make an eclipse, right? So let's see. Here we would have, you can see the tilted orbit. Here, maybe I'll show you close up. All right, so as you can see, here is the push pin, and our lunar orbit is tilted. So it doesn't go straight around the Earth, but is actually on a tilted orbit. And our moon, if you guys can see here, orbits the Earth. And then as the moon orbits the Earth also orbits around the sun. So the real trick is that the moon has to be in between the Earth and the sun, and it has to be in the right place in its orbit as it goes in between the Earth and the sun. And remember, we have about 12 months a year, so that means the moon rotates around the Earth about 12 times per orbit around the sun. So if you want to do this as accurately as possible, for one, you're going to need a bigger table than I have. And then you're going to need to make sure that the moon orbits the 12 times as it goes around. Now you guys can try to do a little bit more math to figure that out, or you can just sort of do it by feel. Finally, we have our actual flashlight. So this, you can trade out your sun, your ball sun, for your actual light sun, and then use that to sort of try and simulate how the eclipse would work with this model. So I hope that you enjoyed making this eclipse in the cup, which does help to show why the three-dimensional orbits themselves help to make solar eclipses so much more rare and so much more exciting when they do happen. Before I clean up on my craft, I also wanted to tell you guys that when three celestial bodies align, and any three, so it could be planets, but in our case, it would be our moon, our sun, and our Earth. It is going to form what is called a syzygy. And it is just fun to know that there is a specific word that you can pull out on the day of the solar eclipse, just to show everyone how smart and well-read you guys are. All right, that's all for the craft. All right, so that is all for our elementary experiments solar eclipse study. I hope that you guys learned a little bit about the solar eclipse and are maybe a little bit more prepared or a little bit more excited about the eclipse that is happening on April 8th. If you would like, you can stop by the library on April 8th. And we are doing just a very low-key viewing party with a couple of crafts. If you would just like to drop in during that time. Hopefully the sky will not be cloudy, so we'll actually be able to see the eclipse as it happens. But otherwise, I hope that you enjoyed learning about it here. And I will see you a couple days after the eclipse on April 10th for our next elementary experiments. So until then, I will have a few books for you to read if you want to learn a little bit more. And of course, feel free to register for that next event on April 10th if you would like to come in person. Otherwise, I will meet you back here on the 10th. Until then, goodbye.